Hey you guys, I hope you're doing well. In this video, I'm going to start talking about STL algorithms. And what are STL algorithms? Well, these are part of the standard template library. That's what STL stands for. And there's a lot of functions that you can use, and they are within like the std namespace. Just like cout, cin, we're gonna cover minimum, and maximum, or min and max, these functions today. But in addition just to showing you these algorithms, I'm going to show how they work under the hood as well. So let's start with mm representing min-max .cpp. So I've already written some tests here. So what we're going to do is that, well, we have std min and std max already. And of course these are what I recommend that you use. But how do these functions exactly work? Well, we're going to reproduce these functions with our own min and max. And actually, as I say this brings me up to a point. This is one of the big reasons why I don't like using namespace std or namespace std. Just because here, I'm going to be defining my own min and my own max. If I was using namespace std, right, if I had something like this going on, using namespace, if I did this and I uncomment this, which min is this going to use? The std min that's part of the standard template library, or is it going to be using the min and max that I'm making myself? If I ask you that question, I mean, you wouldn't have an exact answer. I don't know. And if you're going to be answering, I don't know, well, the compiler is going to be doing the same thing. It's going to be just as confused. So, I mean, this is why I don't like using namespace std, just because, I mean, we create the ambiguity, and you will know, or you will learn in the future as you practice more in C++, that there's a lot of data structures and algorithms and classes and stuff like that that are part of the std namespace. And sometimes you might go accidentally recreating some of these algorithms, right? There's like a rotate algorithm, there's a reverse algorithm, and a whole bunch more. And you creating your own functions, there might be a name conflict. It's very easy to conflict those names. So anyways, let's start with how min works. So since this is part of the standard template library, we're going to be using templates. So I have my type name t. And now what I'm going to do is I'm going to return to a reference of the data type that we have. So I'm going to say min, right? So if I take a min between two integers, I'm going to return a reference to an integer. So we begin with two inputs. We're going to get a reference to a const reference to b. What we're going to do can all be done in one line, so we'll say that it is simple to implement, but just because it seems simple, it all being done in one line doesn't mean that it is. This is a conditional operator, where here we have a statement that we want to test. We have a question mark. If this statement that we want to test is true, we're going to be returning this result. Otherwise, if it's false, we're going to be returning this. It would be the same thing if I converted this to an if statement. This is what it would look like. You see how we have our conditional statement here has the same structure as an if statement. So we have what we want to test. We're going to say is a less than b question mark. If it's true, we're going to return a. Otherwise, we're going to return b. So this in one line does what we do here in like 6 lines. So it's pretty neat. This also works with variables. Let's say, for example, we wanted to add an extra step and we have a t and we have a temp. We can set it equal to this and it'll do the same thing. It'll do this, which is pretty wild. And I mean, converting this to an if statement would look like this. So it's quite similar. We have a conditional statement, we kind of test it, and since we're assigning the result to a value called temp, it's like doing this. Actually, that's probably what it'll look like to be more accurate in the conversion of the lines. But this is doing the same thing. And you know, these can get a little bit more complicated, and you can actually have conditionals within conditionals. But for this case, I don't want to get too complicated, so we'll leave it at that. So we have our min. We're going to test a and b, If A is smaller than B, we're going to return A, otherwise we're going to return B. And you might think of a case like, hey, what if they're equal? Or if they're equal, it doesn't matter which value we return because they're both the same value. But in this case, we will be returning B if they are equal. Now, if I want to change this to max, it's quite simple relative, to doing other implementations. I just change this to the name of max and I flip the sign. So if A is greater than B, we're going to return A, otherwise we're going to return B. So now that I have my template code written here, why don't we go and test this out? That's pretty good. It looks like our code is working. And now that we've written these functions on our own, these are the implementations of how std_min is implemented and how std_max is implemented. We're going to comment out our homemade algorithms and we're going to uncomment the std algorithms, the STL algorithms. We have the same result. So I hope this sheds some more light on some of the STL algorithms that are available. I, of course, encourage you guys to look at them. I encourage the use of STL algorithms just because they are algorithms that have been tested and debugged, and you are guaranteed that they're working. Like in past videos, I've gone about implementing queues, linked lists, stacks, my vector class, and I myself implementing these. I mean, they could be full of mistakes. I could be missing things. But using, std vector or std list or std stack or std queue, those classes have been fully implemented, debugged, right? There's nothing funky about them, and I don't have to worry about there being errors, unlike if I wrote my own. If I wrote my own, I'd have to do my own testing and stuff. But on the flip side of the coin, it's really good to understand how the STL algorithms work underneath. Just in case for some reason you don't have access to some of these, you can re-implement the algorithms just like in the standard template library. But that about wraps it up. Thanks for watching, and in the next video I'm going to talk about std accumulate, which is a pretty good sum function, so that way you can sum the contents of an array or a linked list or something like that. No, the test will be focusing mostly on the vector class, but this can work for std list and actually std stack and std queue, those data structures along with other ones. But anyways, I'll see you for that video.